In this problem, we have a hamster running in a wheel whose radius is 15 centimeters. The hamster is running so fast that he has the wheel turning at 33 revolutions per minute. Remember, a revolution is just one time around the circle. The first question is, what is the angular velocity of the wheel? And note that they want my answer in radians per second. So the given information is in minutes, and I need my answer in seconds. So I'm going to start by writing down what was given to me, and that was the wheel is turning 33 times around the circle every minute. The first thing I may want to do, since my final answer needs to be in radians per second, I'll write that over here, and I think of that as my goal. How do I get these units of revolutions per minute converted into radians per second? I'll start with the easy one, and I'll multiply by a unit fraction, and I want to convert minutes into seconds. Since minutes is in the denominator of the fraction, I need to put it in the numerator to get them to cancel. That will get rid of minutes, and my goal is to get seconds into the denominator, so I will write seconds in the denominator. Now I just have to write a true statement here that relates minutes and seconds. For example, 1 minute is equivalent to 60 seconds. Technically, I'm multiplying by the number 1. Since 1 minute is 60 seconds, you can think of this as 60 divided by 60. Now, minutes will cancel, and whatever 33 divided by 60 is, I am now in revolutions per second. So at least I have seconds in the denominator. Now I need to get radians in the numerator. So I need to convert revolutions into radians. That's actually pretty easy because I know that one revolution, one time around the circle, is 2 pi radians. So once again, I'm just going to multiply by a unit fraction. Whatever I write here is going to be equivalent to the number 1. It's a unit. And I want to get rid of revolutions since my final answer doesn't have revolutions in it. Since revolutions is in the numerator, I will write it in the denominator to get them to cancel. And I want my answer to be in radians, and radians is in the numerator, so I'll write it there. And once again, I will just make a true statement that one revolution is defined to be 2 pi radians. Now, revolutions cancel, and I will be in radians per second. So I'm going to turn to a calculator. I have 33. I'm supposed to multiply by 2 pi. The pi symbol on this calculator can be obtained by hitting second and then the caret key. And then all of that needs to be divided by 60, telling me that to a couple decimal places, the wheel is turning about 3.46 radians per second. So suppose the hamster was running on the wheel so that the wheel was rotating this way. What this means is the speed at which it is rotating, the speed at which this angle is changing, is that every second it'll go through 3.46 radians every second. To give you some idea, 3.46 is close to 3.14, which is pi. And if you remember that pi radians is halfway around the circle. So it's going a little more than halfway around the circle. He's making the wheel turn a little more than half of a revolution every second. The problem did not specify how I'm to round. So in this video I rounded 2 decimal places, but you may need more. Let's go on to question B. Question B is different because it's asking for the linear velocity as opposed to the angular velocity. So this question isn't asking how fast an angle is changing. It's basically asking if the hamster was not in a wheel and he was on flat ground, how fast would he be running? And I'm supposed to give that answer in centimeters per second. You could start this part much like I did part A by writing down that the wheel is turning at a rate of 33 revolutions per minute. Since my final answer needs to have seconds in the denominator, in fact I want centimeters per second, I will do that unit conversion at the beginning where I convert minutes into seconds, and once again I put minutes in the numerator so that it would cancel with the unit minutes in the denominator, and since I want seconds in the denominator, I put it in the denominator here. So I know that 1 minute is 60 seconds. Minutes cancel, and I'm in revolutions per second. So that's where we started part A at. The difference now is I need to convert revolutions into centimeters. So I need to know every time the wheel goes around one time, one revolution, I need to know how many centimeters the hamster has to run to make that happen. So imagine whatever the distance around this circle is, the circumference, imagine how much linear distance, if he was running on flat ground, that would have to be so that the length of this red line that I've drawn is equivalent to the length around the circle. Every time the wheel rolls around one time, whatever the distance around the circle is, that's the distance the hamster would be running along the ground if he was not in a wheel, but on solid ground. Imagine if this wheel was made out of string, and somehow you were able to cut the string right here and unfold the circle and lay it on the ground. That would show you the distance that the hamster needs to run to make this wheel turn around one time. We know that the distance around a circle is governed by the formula for circumference, which is c equals 2 pi r. Or, if you're using the formula for arc length, which is s equals r theta, notice this is the same formula where the angle theta was just replaced with 2 pi, because one revolution is once around the circle, which is 2 pi units. So your arc length would be called the circumference in this case because it's the full circle. A full circle is 2 pi radians, so theta would be 2 pi, and you could copy the r. Either way, you get the distance around the circle, the circumference, to be 2 pi times whatever the radius is, and they gave that to be 15 centimeters here. So I'm going to multiply by 15. Since my radius is in inches, I could have labeled this 15 inches. Radians are unitless, so the radius is the only thing that has units in here. So it's saying the circumference is 2 pi times 15 inches. If you wanted, that would be 30 pi inches. And to give you an idea what that is, 30 pi inches is roughly 94.25 inches. So circumference is about 94.25 inches. So every time the wheel turns one time around, the hamster had to run 94.25 inches to make that happen. But in terms of the problem now, I have that last conversion factor that I need. I'm trying to get rid of revolutions. It's currently in the numerator, so I put it in the denominator. I'm trying to get centimeters in the numerator, so I will put it up there. And I just found that one revolution gives me about 94.25 centimeters distance. And revolutions here in the numerator cancels with revolutions here in the denominator. You can see that my final answer is indeed centimeters per second as requested. So on a calculator, I will do 33. I will multiply by, and I'm not going to round here, I'm actually going to use the previous answer feature. On the newer calculators, you can go up, select that by pressing enter, and it'll copy it for you. On some of the older TI products, let me undo what I just did. The older products don't have that feature, and you have to press second negative, which is A and S, short for previous answer. So I'm taking 33, multiplying by my previous answer, which was that roughly 94.25. I'm doing this so that I don't round in the middle of my calculations. Then I divide by 60, and I think I've typed in everything that needs to be typed in. So I press enter, and I get that in centimeters per second, the hamster is running at a linear velocity of about 51.84. Again, I have no directions as how to round, so I'm just going to round to 2 decimal places. And if I remember correctly, that was 51.84 centimeters per second.